Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Julio Godinez, and welcome to today's Security Boulevard webinar, Improving Speed and Focus While Resolving AppSec Challenges, brought to you by Synopsys. We have a great webinar for you today, but before we get started, I need to go through some housekeeping announcements. Today's event is being recorded, so if you miss any part of the webinar, you will be able to. It will be available for you for on-demand viewing. We will be sending out a link to access the webinar on demand, or you can visit securityboulevard.com/webinars, and it will be available for you as well. We want to hear from you, so please feel free to send in your questions at any time throughout the program by using the Q&A tab. We also encourage discussion by using the chat tab, so let us know your thoughts or just say a quick hello. Finally, stick around until the end because we are doing a drawing for 4 $25 Amazon gift cards, so stay tuned to see if you're a winner. Joining me today is Boris Sipot, Senior Security Engineer at Synopsys. And with that, I'm going to put myself on mute, turn off my camera, and let you get started.
Thank you very much. So, really nice welcome also from my side to everybody who is attending. Thank you very much for taking time and joining me in the presentation about how to improve the speed and focus while we try to resolve our AppSec challenges, right? And lately I was talking with my friends and colleagues about how nice it is that we are now going back to normality, right? After a long time of being housebound, let's say it like this, it's again starting to go into a normal way. And also our kids are now returning to schools, kindergartens, and everything. One thing that is also going with this back to normality is also all the challenges that we had before, which in many cases we have forgotten, right? My friends and colleagues mentioned that now that the kids are in kindergarten or in school, they're bringing with them also the normal diseases like flu, cold, or even the stomach flu, right? And I'm also now impacted by this, so if my voice changes, please don't take it bad. But what I wanted to say is that sometimes when we are focusing on one thing particularly, we somehow tend to forget everything that matters all around, right? We forget to see the signals that are also all around us to point us to other things that we should watch out for. And this is also somehow how I feel that we are sometimes feeling in AppSec. We are many times focusing on one thing, trying to make this one thing perfect, make it right. But then again, under the whole focus side, we forget about all the other signals because either there are too many or they are just not so present as a priority that we should handle. And I hope that I can bring you today through this presentation the point on how to regain that focus on a much more broader view and put it together into a prioritized list to handle AppSec challenges. And I want to start with this, right? Today's centerpiece of our life is technology, right? Technology is all over. And if there would be electricity shortage that would take a few hours and our mobile devices and everything would run out of battery, then we would already feel a little bit helpless, right? One thing that we have, we may not forget is that this technology is somehow a part of our daily life in many cases. And this technology is run on software. And now imagine if this software would be somehow impaired or be vulnerable, then we are basically vulnerable ourselves. I know it's a little bit philosophical, however, it is like this. And every time when I speak with customers, the development teams and everything, they are telling me that they are there to resolve problems with their software, right? They're writing algorithms, they're writing code that will solve functional problems, right? However, many times they are then also faced with challenges about application security where they don't find themselves at home. However, there are the right ways how to do this. There are also the wrong ways. And why I say the wrong ways, one thing that we should not forget about our development colleagues is that they are handling really complex pieces of code, really complex software that is not anymore, let's say it like this, just proprietary code as was before. It's not anymore in a lead time of release every 6 months on one or once a year and running just on one operating system, right? We are talking today about more of everything, right? We have more code, not only proprietary, but we are using third-party code. We are using more complex codes running on several different operating systems or platforms, connecting with devices all over, networks, internal, external, mobile. So from that perspective, the complexity of the development and the complexity of maintaining the software has grown really a lot. Now, if we then take into perspective where this software runs and how it connects, then we see that this is not anymore just the Internet of Things, as we used to call it, but it's Internet of everything, right? We have smart devices, we have smart heaters, and I don't know what. However, you have to think that also cars are now belonging into this world, that we are now, through our mobile phones, communicating with the car, getting the settings of the car on our mobile device. We are talking about smart cities, smart governments, where this connectivity should be in the future even more connected. Let's say it like this: people, technology, right? So from that perspective, it's not anymore a software that I use on my computer. It's the software that connects me with everything in the world. Synopsys many times then also does researches on how this software is handled in the world, right? We did the parallel in a pandemic, where we checked out the software running on our mobile devices as we were, as I said, homebound due to the pandemic that we had. And we were using much more our mobile devices in order to do our work. So we were interested, what can we find out about this software that we're running on the mobile devices? And on the other hand, we are every year conducting open source security and risk analysis report, where we look at software and check out how much open source is used and what is the state or quality of this open source that is used in the software. The first point that we saw in the research about the peril in the pandemic was that we took more than 3,000 applications that you can download by yourself on your mobile device from the Google Store. And what was a little bit scary was that every sixth application, or 6 out of 10 applications, were vulnerable. They had some kind of vulnerability. However, when we checked out what those vulnerabilities were, we saw that 94 of those vulnerabilities are vulnerabilities that are fixable. So not even something that you would not know how to mitigate or remove. Those were fixable vulnerabilities where we started to ask ourselves, how can it come so far that so many applications are released with vulnerabilities that should be fixed, right? On the other hand, when we look at the state of open source, we see that the usage of open source is growing year by year. And that's great, right? Well, it's hard to grow because we are already at 98% of the code bases that are using open source one or the other way. And that's great. Open source will help you to maintain your focus on your development by not having to develop hot water, right? So you're taking open source components, you're faster in development and everything. However, we may not forget that every open source component has their legal obligations that you have to fulfill, but also you have to think about security risks that come with this open source components or their dependencies. And now if we think about the licenses, the license compliance piece is getting better each year, right? There are less and less license compliance issues as we see in the software as was the year before. However, when we look at the state of the security of open source components, we see that year after year, more vulnerable components are used. It might be that open source components that were not vulnerable last year are vulnerable now, and they're still used. However, that's a little bit worrying data, right? That the open source components that are used in applications we are using day by day are vulnerable. And if we know about those vulnerabilities, also the hackers will know about this. So we try also, of course, with many different approaches, fix those risks, right? We take the software development life cycle, and we learned in the past years that we have to do something that is called shift left, right? However, for many companies, we came to the problem that they understood shift left wrong. And here I'm coming back to the starting point that I made, that it was then put the pressure of security resolving just on the coding side. So you took security tools, threw them at developers and said, it's your responsibility. However, if we think about the DevOps idea, putting security just on the coding side is not actually handling then the holistic view for application security, right? So putting a security tool just on the coding side will help there. However, it will just put the pressure on one step and will not take the pressure away. This, of course, is the happy news for hackers. As said, if we do it like this or don't do it at all, then we have vulnerabilities that can be exploited. How is this happening? So, for example, if we use open source components, when we use them, an open source component could have a vulnerability that was introduced many years ago. So before it gets found, it could be days, months, or even years that you will hear about a vulnerability in an open source component. Usually it happens because a researcher has took this open source component under his view and found a vulnerability that could be exploited in an open source component. Once this will be announced, there will be even YouTube videos showing you how to exploit this vulnerability. And of course, the hackers will start hacking, right? So they will look for opportunities where they can get now this vulnerability exploited. And here is actually the problem, because here is the run for your money. You need to find this vulnerability before the hacker does. And of course, finding it is not the answer. Fixing it is the real problem. When we talk about proprietary code, the problem is maybe even bigger, right? Because proprietary code is not viewed by anybody else than us in this respect, right? So from that perspective, imagine if you introduced a vulnerability in your source code, before you will find it, it will be days, months, or even years that this will come out, right? The whole time that this vulnerability is in your code, somebody will search for it. So it doesn't here mean that you will find this vulnerability. The hacker has also tools to search for vulnerabilities in your proprietary software, in your proprietary code. Let me say it so, right? And this means that usually the hacker is the one finding the vulnerability before you. So usually a security breach will happen, and then you will see that you had a vulnerability that was exploited. And this means that you're living in a constant threat state, right? Constantly you are there and wondering, will something happen? Well, to avoid this, we have something called DevSec ops state, right? Where we talk about implementing security into every step of our DevOps process. And this helps then also the velocity. Even though we would introduce security tools into every step of our infinite loop, we would fix vulnerabilities where they matter and at once, which means that they would not go into the next stage and they pile up. So think about the coding thread. When we are coding, we could do everything right. However, everybody has a bad day. Everybody wants to finish sometimes earlier. And security thinking is not something that most of the developers would learn in school, right? So it could happen that you just introduce an SQL injection in a really simple piece of code that can be later abused in order to enter your application, the data of your customers, or even your own network. To avoid this, you could already use SAST technology on the coding stage. That's right. Here you help developers, maybe even introducing SAST in the IDE so that they see right away, oh, here I made a mistake. I have an SQL injection. I will repair it right away so that it doesn't go into the next stage. The next stage being, of course, the build time. What kind of things could you resolve during build time? Well, imagine this. When you're building your application, you're of course building in certain packages, third-party, open source. Those packages also have dependencies on other packages that have then dependencies on, again, other packages. We call those direct dependencies or transitive dependencies. Usually, the direct dependencies we quite good know because we put them in. Transitive dependencies are the ones where the problem lies. And now imagine one of those is vulnerable. When we are building our software together, this vulnerability has a good chance to end up in our software, and by this, giving the hackers the opportunity to hack our application because we missed this vulnerability. To resolve this problem during the build time, you are using SCA or software composition analysis tools that tell you, okay, those are the components you're using, those are the license or security threats that are coming with them, and this is how you resolve those if your tool helps you with this also. So from that perspective, you can be sure that you can handle any reported open source problem before it gets into the testing phase or even the release phase. However, now, usually when we are doing testing, we are focusing on, can I use this application? Is this feature working? Can I log in? Can I press this link and it will take me to the right page? Will it fill up with the data that I wanted, right? However, this functional testing can be also aided by something we call IAST testing, or interactive application security testing, where each of your functional tests would be also, without any interaction from you, would be followed by a security test. And this test would then tell you, hey, watch out, when you pressed this link to log in, not only did I found that it works correctly, but I found also an SQL injection that I could even prove that it's there. And now you have enough data for the developer to fix this immediately without searching for problems, because the whole problem is there for him. So now imagine if we now have the DevOps infinite loop, and we already are aiding our process by those 3 steps. Imagine how fast you could resolve your application security problems, right? However, we come now to the other side of complexity, right? And this is about this picture, right? Whenever I show this picture to developers or IT personnel who has to take care that everything is running smoothly, and tell them, hey, you can introduce security into this DevOps loop, then I get sometimes a little bit weird views. They're not believing this, or they're missing something, right? And the missing point is that this marketing slide is maybe too clean, and it comes forward as we are not understanding the point. And the point is that this DevOps side has tools that have to be integrated, right? Developers are using their IDEs or repositories to build, to store and to build the code and so on. Then you have build tools that are there to build your code into a useful application. Then testing suites that will test your applications need to be deployed. Also, the CI and CD tools to release or support the release process, deployment process with the different technologies, operational side, monitoring, where you gather all the data that you can give then further to the developers, again, in order to plan for the next release, right? And now when we talk about security tools, now those are again on this side adding, as we said, SAST tools, SCA tools, IAST tools, maybe some network security tools that are checking that our running application is running good, doesn't have vulnerable ports open, that everything is running unbreakably well, right? And then in the end, maybe still some container tools for checking running containers that everything is unhackable. Well, now, as I said, the complexity is not anymore about finding the vulnerability, but now the complexity starts in how to gather all this data and make sensible reports out of this, right? So now imagine you have now your application, but you have to look at your application not only from the code side, but also from the third-party side and also from the networking side on which this application now runs. So this means that you don't have only one tool to look at. You have several different tools. You have several different manual processes that you have to follow. And many times it feels like we don't see the woods of all the trees, right? And now somebody tells us, create a report that will show us all the problems. And then you have the security team that has to now gather all the results from all the security tools, take those in and create a report, which usually ends up as an Excel sheet. It's not hard to say that here, not only you have a problem, but you're missing a lot of things that are important, because in this mass of information or data, let's call it like this, in this mass of data, it's hard to take out the right information to act on it. So whenever we are faced with such challenges, we are talking about two things. First of all, it's pipeline congestion, because we are running so many tools that our application development is not moving in the right speed, right? We are losing velocity because everything tries to be run. And then in the end, we have so many data that we don't even use it, but just publish the application and say everything is okay, right? The second thing is that we have too many data, right? And we say, okay, we now have to prioritize. But how will you prioritize if one tool tells you this, the other tool tells you that? Where will you see the correlation? Where will you see that this is now the priority 1, and this is priority 2, and this is priority 3? Many times you will see that there might be an idea, a legend about a one tool that will solve all the problems, and that's not the case, right? There is no multi-layer tool that can do everything at once at every stage. You still need those separate points of interaction, the separate point of the development side security and the runtime side and the deployment side of the security. However, you still need to use all the capabilities, right? You have a lot of AST tools that will help you. You have education, which you need to take in order to recognize what those capabilities are and how to handle them. And believe me, if you just throw a tool at a developer without educating them on this, it will be hard. Therefore, it is good to have tools that have even integrated learning capabilities, so that when they show a vulnerability, they can even teach you how or why this is happening. Secondly, managed services. If you take a use of them, you can fit your resources to the right angle, right? We all know that we have things to do, and many times we don't have resources that are just sitting there and waiting that we give them a task, right? This means that if you take managed services into use, you can handle your development normally, but somebody else can help you with the security onboarding side. But now, as I said before, the one missing cornerstone for everything is then the consolidation and triaging piece. You need to have a good overview on what's happening and act on those results. So first of all, when you're thinking about AppSec prioritization and correlation, your solution will have to, first of all, execute tests when they are needed. Then it has to correlate all the results so that all the security tools that are reporting findings can be put into one view, and you can then see, okay, this one vulnerability was reported from all the tools, and I can handle it like this. You have to prioritize them, and you have to have the capabilities how to prioritize all those vulnerabilities that will be let's say it like this, reported to you, so that you can work them down from the highest priority to the lowest. And then you have to track the remediation, right? It doesn't help you if you do everything but don't know that you have done it. And in the end, you need to have a centralized risk visibility, meaning that you have to have for each and every team, for each and every one who is responsible for the security side and taking care of vulnerabilities, that he can see what was reported, what was handled, and what is still missing. And of course, this all has to fit in your CI/CD pipeline. The solution we have. So there is a possibility how you can put your AppSec program. So this, what you imagine to be your AppSec project, into a form of policies where you say, okay, those are my policies, my gateways, and you can then use intelligent orchestration, an intelligent pipeline that will not blindly just run each and every tool every time when something happens, but will decide based on policies when a certain tool has to be run, how it has to run, and where it has to be run. The next thing is that your DevOps pipeline will work its normal way. It will use all the AST and other results and will pass them on to the code DX. This is how our tool is called for correlating those results. It will put all the results in there, and based on those results, CodeDX can then create actionable risk profiles and tell you, here is what you have to focus on. Of course, there is a little bit of AI and heuristics behind that it can resolve and find correlations between those issues and also bind them to certain standards like HIPAA or PCI or others. However, the important thing is now that you're not only creating this actionable view, but also connecting it to your ticketing system so that you can do actions based on those recommendations. Once you have this done, then you see that you have put your automated test results and also all the manual test results into one single pane of glass, and you can see what is happening not only with your project, but actually with each and every project that you are running. And this on all three stages: code, third party, and the networking on which this application is running or this project is running on. Thank you very much for listening. And yeah, Julio. That was a good question. So one thing is that you can improve velocity by adding tools. However, as I said, you have to add the right tools in the right process step so that the right people can work with those tools and handle them, right? So for example, many times it's like this, that somebody takes the SAST tool and tells the developer, okay, here is your tool and do everything with it. Or gives the SAST tool to the security team, right? Now imagine you have 300 developers and 5 security people. How can this even work? Security team will maybe be able just to pile up tickets that you have to repair. The development team will not find the right way to fix those. Therefore, as I said, SAST, it maybe makes sense going into the IDE so that the developers have their own view on how to resolve the issues. The build managers have their own view on how to resolve third-party components that are there, or even the developer that he not even introduces vulnerable components in the end. And this all saves time in the end so that it does not pile up before the release where somebody says, oh, stop, here you have a vulnerable code, back to the drawing board, release is postponed. And now imagine how much it costs time and money just to postpone a release of a software for 1 week or 2 weeks, right? So from that perspective, I'm talking about adding right tools at the right moment can increase velocity and help you with resolving issues. On the other hand, when we have those tools, and not only those three that I presented today, the SAST, SCA, and EAST, but also imagine you have now Tenable, maybe Nessus, right, where you're scanning the application in a sense of a black box, trying to do breaking into that black box, right? There you get also security results. Then maybe tools like Aqua or Sysdig might give you information on a certain container aspect, where the vulnerability in a container is while it's running, right? And all of this is then even adding on those vulnerabilities. Now, if you prioritize one over the other, then you will always have this who has more saying. If you're using something like CodeEX, then it helps you to prioritize, maybe even find the same vulnerability that Aqua found while container is running in your code, and you can correlate those two and fix them so that both are then satisfied in the end. And this is how it somehow doesn't clash what I said in the end with what I said in the beginning.
Excellent. Second question. Why can't I look for vulnerabilities in the whole code with just SAST? I mean, why can't I investigate also OSS components with SAST tools? Why would I need especially SCA for that?
Yeah, get this question a lot of times. So imagine when you're doing code scan with static analysis tools like Coverity, for example. It will run through your code, it will find all the bindings to which code segments and functionalities you're connecting during the build or whenever, and will tell you, hey, watch out, the function you're calling here is vulnerable here, and you should repair this input because it's a I don't know, cross-scripting vulnerability or anything else, right? So when it goes for your proprietary code, that's still okay. You should handle this. But when it goes for open source components and all their direct and transitive dependencies, that would be an overload for a security team or a development team to take care of this themselves. They would actually have to repair everything, look for solutions to repair this, and gather information on things that is already given to them on a silver platter by SCA. So it's always like this. Yes, you can do it by yourself. However, you have to ask yourself, is this too complex and time consuming for me to handle? Would it not be easier if we use SCA tools that tell me, hey, here you have an open source component that has this direct dependency, get an update of this component and you will resolve the vulnerability. That's now a few seconds versus maybe going through the whole tree of vulnerability connections and trying to resolve this by yourself. This is why you should consider SAST and SCA in the end, both and not just SAST.
Excellent. We have a question from Paul here. Good insights into AppSec. How critical is API security at present in ensuring a comprehensive AppSec plan?
That's a great question. Why I like this question especially is that today there is almost no application anymore that doesn't use APIs, right? API is your connection to talk how two softwares or two devices talk with each other, right? So now if you don't have an AppSec plan for your APIs, how can you make sure that you are knowing who is doing what with these APIs, or where does he land, or what kind of authorization he needs in order to get the data that he's requesting for, right? So we have seen many cases where, for example, the API was abused. Well, it did not need a lot of abusing. It was just using the API and taking the security keys that are in the code itself, right, hard coded, and you could download all the data of the customers that this company had, right? We had problems. We've seen that some products did not have this API security plan, right? And they forgot an endpoint where an unauthorized user could again access all the data on the back end, which he should not even get if he would be an admin, right? So from that perspective, you need to watch out what APIs you have and how do those APIs, or how are those APIs able to be used.
Very good question. Next question: does your solution code DX then cover only Synopsys tools and services?
No, that would be, let's say it like this, a little bit too self-centered, right? So as I said, there are many tools, even tools that are in the side of DevOps that we don't handle, right? We are still in the point where we say that we are good at what we do, but other things we let companies do that focus on that side, right? So, for example, why would we do Tenable results when Tenable is already good at finding holes in the applications and so on? So, from that perspective, CodeDX is not covering only Synopsys tools, but it has support for, I think we are now at 75 security tools all in all, be it on the AppSec level, be it on the networking level, be it on the third-party level. So from that perspective, if you have interest, if you have your own tools, if you would like to set up some idea how we could help you in your environment, let us know, and we can also see how to bind in the tools that you're already using, of course, together with our tools also in the end. Excellent. And services, of course. Sorry.
Excellent. So we still have plenty of time for questions, but in the meantime, I do want to remind you that today's webinar has been recorded. So if you missed any or all of the webinar, you will be able to watch it again. We will be sending an email with a link to access the webinar on demand. The webinar will also be available on Security Boulevard. Just look in the on-demand section in the webinar page, and it should be there. The 4 Amazon gift card winners for today are Jim F. Congratulations, Jim. Emily B. Gervais B. And finally, Mike S. So congratulations to all our winners. We'll be reaching out to you via email with instructions for claiming your Amazon gift card. So please check your inbox. And if you don't see it there, please check your spam folder. Taking one last look at Q&A. I don't think we have anything. Boris, thank you very much for taking the time to put together this presentation. It's very insightful, and I hope our attendees learned a lot from it.
I hope also too, and if there are any questions, you can find me online. You can find me also over Synopsys, so I would be more than happy to answer your questions also offline.
Excellent.
Enjoy, everybody. Thank you very much for joining me in this presentation today.
Absolutely. Thank you to the audience for their time and engagement. This is Julio Godinez signing off until next time. Be well.
Thank you. Bye.